So again, we want to wish everyone a good evening and welcome to tonight's presentation on the February 25th snowstorm. I'm Joe Deli Carpini, the Science and Operations Officer, and with me is one of our lead meteorologists, Hayden Frank, to take you through this storm. And I will start off by tossing it off to Hayden, who's going to take a look at an overview and some of the forecast challenges associated with this winter storm. Hayden, go ahead.
All right, great. Thank you very much, Joe. So this is a look at the total snow that was observed from this storm. Basically, you can draw a line north of I-90. That was approximately where you had 6 or 7 inches or greater. Generally a 6 to 9, maybe some localized 10 inches amounts north of the Massachusetts Pike towards the New Hampshire border. And you'll notice once you get about 10 miles south of the Massachusetts Turnpike, I-90, snowfall drops off pretty quickly to more of a 2 to 5 inch storm. And what you'll notice here is there is no real difference between being on the coast and being further inland. A lot of times, especially early in the season when the ocean is a lot warmer, you kind of see the opposite where you can actually be further southwest and get more snow. But if you're too close to the ocean, especially within a couple miles of it, you end up with mainly rain, all dependent on the exact track of the storm system. So looking at what led up to this storm, we actually had, if you remember, record-breaking warmth pretty much a couple days before. We had temperatures up in the upper 60s and low 70s. So you're not exactly thinking a significant snowstorm. And the upper level features were not that classic big snow event for southern New England, but they were more of an indicator of a front end thump. And we'll talk about that in a bit here. But to get the general sense, we're talking about a strong high pressure system over Quebec with a low pressure system cutting underneath. And you kind of get what we call southwest flow aloft, say 10, 20,000 feet in the atmosphere over that cold dome. And again, we'll talk about that in a little bit here. The biggest uncertainty was how quick the warm air aloft would move in. That was going to change the snow over to more sleet and in some cases rain. And we kind of see the model battles there with the NAM tending often to handle these situations best with that warm air moving aloft. Not always, so you have to be careful when using that, but it tends to handle that mid-level warmth the best. The GFS was too cold in the mid-levels and kept too much snow south of the Massachusetts Turnpike. Often the inverse is true at the surface. The NAM is usually right with the cold air sticking around at the surface. The GFS tends to warm you up too much at the surface, while it's the opposite in the mid-levels of the atmosphere. So just a little forecaster tidbit there. But we'll go on to the next slide here. And again, the areas just south of the Massachusetts Turnpike did fall just short of winter storm warning criteria. Again, that's usually 6 inches or greater for the criteria. A lot of areas were in the 3 to 6, 2 to 5 inch range. But regardless, in terms of a commute Friday morning between 7 and 10 a.m., that was when the heaviest snow was falling and certainly made for messy roadways. So a lot of it also depends on precipitation intensity. Sometimes the warm air comes in aloft, you can flip to sleet, but then you get another really heavy band and you temporarily go back to heavy snow. So that's something that we need to keep in the back of our minds when we're forecasting this type of event. So we're going to take a look at some of the model data, and we're going to kind of start aloft here. So when I say aloft, we're looking at 500 millibars, so roughly 20,000 feet above the ground. And what you'll notice is, we're looking at more west to southwest flow, and the main energy, look where that's tracking. You can see that what we call the short wave in red. It crosses the Great Lakes and moves to our north. So that usually indicates more of a front end thump. It's not that you could get very significant snow for usually a short period of time, maybe like a 3 to 6 hour time frame, where you get snowfall in at 1 to perhaps 2 inches an hour. And then sometimes you dry slot. When we tend to get our big 10 to 20 or even more inches of snow, like the blizzard, we usually see that shortwave energy tracking to our south. So it's important to look aloft, and that's going to give you an indication of what might transpire. So we're going to go down one more level here. We're about 700 millibars now. That's roughly around 10,000 feet above the ground. And what you'll notice is there's the 700 millibar low. It's somewhat open. Usually, like we see that more closed for a really big storm. You can see it close off temporarily, but look where it tracks. It tracks across the northern New England Canadian border. And for big snows in southern New England, usually like to have that pass over you or just south of you. So that's something that as forecasters, we really look at, not exactly how much precipitation the model is putting out, but the track of the upper level features can give us a really good idea of how much of that may accumulate. And coming down more towards 850 millibars, say we're roughly 4,000 to 6,000 feet off the ground here. Again, the 850 low, it is closed, but again, the center of it looks to be tracking generally to our north. So you kind of see it close off near the New Hampshire, Massachusetts border as it moves east. So what that allows, usually if those mid-level lows pass to your north, drier air tends to come in up from the southwest. So that kind of cuts off the second half of your potential snowstorm. So you get a big front end thump, and then you kind of dry slot. So the models can be printing out a lot of precip behind that, but it's usually inefficient snow growth where you have really small flakes, or sometimes you've turned over to rain or drizzle. So this is a really important field we look at. This is something called frontogenesis. Remember, the Earth is always trying to stay in balance with unequal heating. So what happens is you get a very strong forcing as that southerly, you see those wind barbs pointing from the south to the north. That's that southerly flow of air pumping over that cold dome of air at the surface. And you see where that's really intense there for a few hours, that purple, that's when you're looking at 1 to 2 inch per hour snowfall rates. And that's your front end thump. But look what happens behind that. You kind of see not much, and then you kind of dry out with westerly flow. So these are usually quick hitters, front end thump, very heavy snow for a few hours, and then it shuts down. And this is a simulation from the NAM of what it was forecasting in terms of precipitation. Now this is looking at the surface here. So you can see the surface low pretty much staying to our south. It passes over Nantucket. So if the surface low stays to your south, what that means is at the low levels of the atmosphere, you're going to stay cold. So you're probably not going to flip to 55 degrees in rain unless you're early in the season with a really due onshore flow off a mild ocean. You're going to probably stay cold. So you're not going to be melting a lot. But because those mid-level centers are going to your north, you kind of dry slot. And even though the model's showing snow there lingering, you'll see the heaviest snow, it flips to ice, little sleet, and then you get kind of lighter snow on the back side of it. But again, the big window for this was during the morning hours, that Friday morning, and then just light, slow and flurries behind the system in the afternoon. And again, if you've been on these presentations, webinars before, one thing we like to look at is the HREF. It's an ensemble. We're throwing some of our high resolution computer models together and kind of coming up with a average per se. So this is a look at things from the HREF around 1 in the morning. You can see we're still dry. Here comes the push, that southwest flow. You can see snow and ice breaking out across Pennsylvania. And as we advance, you'll see this push further northeast. So now we're towards daybreak, roughly 4 in the morning. You can see lighter snows overspread eastern Mass, heavier snow starting to pick up in western Mass. And then just north of New York City, that's where your heaviest snow is into southwest Connecticut. And further southwest than that, the precipitation is already changing over to sleet and rain as that mid-level warmth is surging northeastward. And now we're about 6 a.m. Now, this is one thing we look at quite a bit. So this is an indication from the HREF at, say, 6 a.m., as rush hour is really getting going here, the probability of 1 inch per hour or greater snowfall. And that's a really good signal. Look at that. Pretty much all the area is in, 60 to 90%. And that's something we let, some of our users, our higher end users, such as the DOT emergency managers, that's really means the world to them, because if these snowfall rates were coming in, say, 5 hours later, maybe they're not as concerned. It's in between the rush hours. But if you're getting this during the heart of the morning rush hour, that's definitely going to affect how they're planning their operations. Whether things are going to remain open or closed. Those things they're really looking at is those hourly snowfall rates, and will the plows be able to keep up? Once you start getting over 2 inches per hour, it becomes a very difficult task, even if you have a lot of plows on the roadway, to be able to keep up with the snowfall rates. So, and this is a look at the precipitation type at 12Z. This is from the HREF. So pretty much everyone is snow. Now keep in mind the NAM, which tends to perform well, was a bit warmer than this. So the sleet line did advance further north than the HREF indicated, but it was still a very good simulation and really got you in the ballpark here. And as we move further along, now we're around 8 a.m. And what you start to see happening is the probabilities of 1 inch per hour snowfall rates are rapidly diminishing, say, south of the Providence area. And part of the reason is because that warmer air is coming in aloft. And now as we get to 10 a.m., you pretty much have to be north of Massachusetts Turnpike. South of there, you're just dealing with sleet and a much lighter precipitation, as we call it a dry slot in the mid levels of the atmosphere, comes in behind this and kind of puts an end to the heavier precipitation rates. So again, with these front end dumps, it's usually it pounds for 3 to 4 or 5 hours. That's where you get most of your snow, and then you're dealing with just nuisance stuff, whether that's light snow showers or flurries or drizzle the rest of the day. And again, 18Z, so this is early afternoon. The sleet line did kind of freeze up around the Massachusetts Turnpike. It didn't make it too much further north than that. But what you'll notice is by this time, those dark blue shades of snow have really moved off to the north and east. You really see them way out over the ocean now. And we're dealing with more light snow showers, stuff that's easier for snowplows to keep up with. And keep in mind, it's still late February, but that sun angle, you're a couple months past the winter, actually when the sun angle is the lowest in late December, so you can start to melt some of that on the roadways too. So that definitely alleviates some travel issues as you got into the afternoon here. And then again, this is what we're looking at around 4 or 5 o'clock towards the evening rush hour. You'll see a lot of light snow, showers, flurries, but the precipitation intensity is rather light. And there's already been a lot of salt treatment on the roadways. So not too much of an issue. The one issue that happened is where temperatures actually got above freezing, pretty much southeast of the I-95 corridor, Boston to Providence, colder air wrapped in behind that. So there was a flash freeze where, untreated roads became very icy behind that, even though wasn't really a result of falling snow, but somewhat of a rapid drop in temperatures from, say, the middle to upper 30s back into the 20s. And again, by 7 in the evening, dealing with just light snow showers and flurries, really not amounting to much. So pretty much all the damage was done Friday morning with just nuisance precipitation in the afternoon into the early evening hours. And this was a look at the href, the what we call the match mean, and it performed really reasonably well. What you'll notice is it was a bit overdone. You'll see these yellows, 12 to 15 inches north of, say, Route 2. And then you had basically 6 to 8 inches south, basically from the Providence to Taunton line. And, it ended up being a few inches less than that. So a couple reasons there. One, a lot of times it's not always the case, but if your mid-level centers go to your north, it can be tough to get more than 10 inches of snow because that mid-level dry air tends to cut things off. And also in these southwest flow events, then there is a tendency for that warm air aloft to come in a little bit quicker than the models suggest. The NAM can often be onto that, so that's another factor that comes into play. So with that, I am going to turn it over to Joe, and he's going to talk more about how we messaged the uncertainty and where our confidence was greatest with this late winter storm.
All right, thanks, Hayden. So yeah, this definitely was a challenge, even in the days kind of leading up to the snowstorm or winter storm. So a lot of our snowfall forecasts, and you may have seen some of these on social media, but these were also briefed to emergency management officials, really highlighted the area of uncertainty. And as Hayden talked about, that was across Connecticut, Rhode Island, and southeast Massachusetts, where we had that uncertainty. How fast would it change to sleet? How fast would that dry slot get in? And we certainly had much more confidence in the higher snowfall totals, kind of north here of the Mass Pike along the north. So this has been something that, our partners kind of like us annotating on these snow maps, and we do include them on social media as well, so we kind of share them with everybody. But definitely going into this, that was the area of most uncertainty in snowfall totals. And as you can see here, if you remember, winter storm watches went up for much of the area, prior to the storm. But really, we held on to the watches a little bit longer here across Connecticut, Rhode Island, and southeast Massachusetts, up to the day before, when we converted the rest of the area to a warning where we were certainly more confident. But this really allowed the day shift on Thursday to get another look, at the next model runs and decide from there, do we go winter weather advisory, do we go winter storm warning? So the midnight shift did a nice job in kind of not locking them in. I know when we were, working at the office and in this particular case on the midnight shift, it's okay, time to go to warnings or advisories. And well, not always, you want to get the lead time as much as you can. But in this case with the uncertainty, it was a pretty wise decision, to hold on to the watch, see what the next model runs have done. Do they get warmer where this really, the snowfall totals go down, or does the warm air get delayed where the snowfall totals may need to be increased a little bit? So that's why on occasion you'll see us hold on to a watch for parts of the area a little bit longer than you might think. And this was certainly one of those cases here. Certainly in southern Connecticut, it looked like a much less of an impact. So winter weather advisories were issued there. And again, to the north, a little more certainty on heavy snow. So it was a good decision to go to warnings there early on Thursday morning. But the other thing was on Friday, we did a quick briefing, and that's here. I'm sorry, no, this is the text of the same one. I'll get to that next in a minute. But just to show that winter storm watches were converted over. So this was the next day, actually, up at the top. So you can see a nice forecast update was issued at 7:30 in the morning, and keep in mind, our mid shift goes till 7:30 in the morning. So this is right at shift change time, a new day shift coming in, and the mid shift is kind of heading out the door. But at that point, we kind of have to go by what the weather does, and the change to snow over to sleet was occurring a little bit faster than expected. So you can see we updated the snowfall map here on the left. And this was additional snow. So this is essentially 7 a.m. and later. But you can see amounts were drastically reduced across Connecticut, most of Rhode Island, and much of southeast Mass, and sped up the timing of the transition from snow to the wintry mix from south to north. So you can see these areas near the coast had already changed over, and it would only be about 2 to 3 hours before that changeover line got up to pretty much right to the Mass Pike. That's pretty much spot on. And then by early afternoon, farther to the north. So the two, best practices that we took from our staff was holding on to that watch a little longer in the south and doing a timely update here as the situation was kind of unfolding Friday morning. All right, so let's take a little bit look at an analysis, and this will kind of go through the real time of what Hayden had showed. And again, we'll start up aloft. This is 500 millibars, 20,000 feet. And notice we've got that southwest flow aloft that Hayden mentioned, pretty strong jet streak. So this is a larger, kind of an area of maximum winds embedded within a larger jet stream. But notice here's our upper trough moving across the eastern Great Lakes. And it's going to, based on this, it's going to be remaining north of us. So those model forecasts were pretty much spot on in keeping that trough to our north. And this is a thing we look at from the jet stream. We can get lift from the upper level jet, which is up around 39, 40,000 feet, and also the lower level jet, which is around 5,000 feet. So where you see the blue and the purple and the red kind of overlaid on one another, that's where we get some what we call coupling of the jets. So you're getting some enhanced upward motion or enhanced lift. So this was about 9 in the morning, and this is pretty much as that front end thump was starting to work a little bit offshore. But you can see, in addition to everything that Hayden showed, mainly that frontogenesis and the contribution from those mid-level lows, you've got added energy and lift from the jet stream to really help give us a good front end thump of snow into the mid-morning hours across our area. So looking a little lower, this is 5,000 feet. Again, our 850 low is pretty much centered near Rochester, New York, and you can see it's evident it's going to pretty much stay to our north. But note the strong temperature gradient here. So you can see by the dashed lines, these are below 0 Celsius and then above 0 Celsius in the red. But we've got this tight packing of these contours. This is indicative of a tight, what we call temperature gradient or thermal gradient, and that implies a lot of low-level forcing or lift. So we're getting some good lift at 5,000 feet as well at 9 o'clock in this area. So remember, we've got all this stuff going for us for a good burst of snow on the front end of this storm. And looking at the layer here, this is from 925 to 850 millibars, similar to what Hayden showed in the model forecast, but this is in a layer, so you're about 2,500 to 5,000 feet. And notice we've got this strong band of frontogenesis near the south coast. This would eventually push off to the east, but our strongest band of snow is typically just to the north. So right now, this is kind of favoring areas, maybe northern Connecticut, northern Rhode Island, and getting close to the Boston area. So you're getting that really good lift from that temperature contrast. Now, if we look at some of the surface temperatures, just to kind of show our coastal front, and again, with most of our winter storms, we see this feature. It's the boundary between the milder air off the ocean, usually due to some sort of easterly flow, and then the colder air inland, where we have more northerly or even northwest flow. So it's this boundary that we call the coastal front, and just to the west or northwest of it is typically where our heaviest snow will fall. So this is 1 a.m., and the coastal front at this point had formed. You can see temperatures are 31 and 30, or even a little bit above freezing here on the Cape. While inland, it's in the mid to upper 20s. So nothing was falling yet. As you remember, the snow was just getting across Pennsylvania and getting close to New York City. So nothing's going on yet. But the coastal front's getting set up, and that's an important player in a lot of our winter storms. So notice by 4 a.m., it's made a little bit more of an inland progress. You can see here, Boston's gotten to the upper 20s. You can see some snow. These stars mean there's snow falling. So we've got a good temperature contrast, mid-20s in the interior with kind of northerly flow, and we've got low to mid-30s on the east side with easterly flow. So you can imagine the winds coming off the east and into the north. You're getting some convergence right along this boundary. This is starting to enhance our snowfall across just to the west of the boundary. So metro west areas of Boston into northern Rhode Island, and even parts of coastal Connecticut. Then by 7 a.m., it's made a little bit farther progress, but this is typically where it will, kind of stall out unless there's stronger forcing. But note here over the ocean, the more of these little barbs we see, this is 20 knots or almost 25 miles per hour of easterly wind coming in. So again, temperatures holding in the low to mid 30s. Again, ocean temperatures aren't especially warm this time of year, But this 25 mile an hour air, so imagine it's moving 25 miles an hour, it's running into air that's only moving about 10 miles per hour from the north. So you're getting very good convergence in this area. So by 7 a.m., it's no wonder also that we're in the peak of the storm with this front end thump, and we're getting heavy snow across northern Connecticut into northern Rhode Island, central and eastern Mass. So again, the presence of this coastal front at low levels is going to focus the convergence, and everything else that Hayden showed you that's up aloft also contributes to more of an enhancement for heavy snow. Now, by 1 o'clock, notice the boundary hasn't moved very much. It's changed shape a little bit, but it's holding around maybe the 495 corridor and then into northern Rhode Island. So it did make a little more progress up into southern Connecticut at that point. But notice the cold air is starting to push south. So it's actually, if I can go back, no, it's not going to go back for me. But it's actually starting to drop a little bit south. So some of the cold air is going to start to win out, and eventually as the low that's moving through Nantucket moves offshore, that's going to drag the colder air down and cause this to collapse to the southeast. And you can see by 4 o'clock that's certainly the case. Notice now the front has dropped through Cape Ann. It's moving on the south shore communities of Boston. It's getting over Narragansett Bay, and that has to do with the low moving offshore. Winds have shifted now to the north and northwest and are starting to bring colder air in. Notice it's 23 in Boston. And a lot of these temperatures are going to start to crash here, as Hayden talked about the flash freeze here in southeast Mass and Rhode Island. So that's always a concern following these coastal lows, as it drops that coastal front back to the south. So in summary, despite what we showed, an open wave at 500 millibars and the mid-level lows tracking to our north, we did have heavy snow over several hours from what we call a classic front-end thump. And the biggest uncertainty in our forecast was how quickly that what we call the warm nose or the mid-level warmth would lift north across our area. That's a common challenge for our winter storms. As Hayden mentioned, the NAN tends to handle these situations the best, but even that model can sometimes scour out the cold too quickly. And we didn't show it, but in this case, the GFS was too cold. It tried to mix out the warm air aloft a little too much and kept more in the way of snow. And as we showed you, the HREF was also a little bit slow in doing that transition, but that would make sense because remember, it's an average of several of these high resolution models. So it's not unusual to see one model kind of outperform even the ensemble, but it does always show the right signal. And our best practices that we took internally was the midnight shift, holding on to the winter storm watch overnight. Due to some uncertainty with the northward advancement of that wintry mix, which allowed our Friday day shift to take another look at the model data, as what we call the 12Z runs from the day shift, before making that final call to go to warnings and advisories. So that will do it for our presentation. Don't see any questions in the chat, but we'll pause here and see if we have any coming in. So actually, we do have one. So Hayden, you can join me once again. And from Sebastian, do you think that the warmer air preceding the system had anything to do with the warmer NAM solution verifying better? Hayden, I'll toss that one to you since it's a forecast question.
Yeah, I would say probably not, because the air mass that came in after that was totally different, very cold compared to what we were experiencing. And I've seen a lot of times where we actually have record cold over us, and if we get those upper level pieces of energy going to our west, we end up with snow sometimes quickly changing over to sleet, freezing rain, and rain, and then you can sometimes be very warm and have a huge snowstorm like the one we're going to talk about next week, the April Fool's storm, if the track is ideal. So I think it's more track dependent. Obviously, if you're really cold to start with, it's obviously going to delay the warmth to an extent. But I'd put the onus more on the track of those mid-level centers.
Yeah, and sometimes, if we have warmth preceding a winter storm, it can have some impact on, some melting of the snow initially, especially if it's not very heavy. But once the snowfall rates pick up, or, we like to say for late season, if it occurs at night, then you can really pick up the snow. So, if any impact would probably be more on accumulations than anything else. But, certainly it did get cold enough and snowed hard enough. That was the main key to get us those accumulations. So, yeah, good question, Sebastian. All right, I'm not seeing anything else, so I think at this point we will pause here. But if you think of something, go ahead and throw it into the chat, and we can answer it afterwards.